Hassan and I are here today because we want to share with you a little bit what does it take to build surprisingly awesome products and how we've done some of that in eBay. And the word surprisingly is something that, refers to the topic of this conference. So I used 20 years ago, I was just thinking about this, 20 years ago I used neural networks when I was working on character recognition in my thesis. And then I went on and did product development and product management, a lot of other things, and neural networks went back into the ivory tower. And I think right now we really have a chance to take deep learning and other advanced machine learning algorithms back out of that ivory tower with the compute power, with the data that we now have to really build products that really make a major big difference in the impact of millions of people around us. If you look at, can we get the presentation up, please? Sorry. All right, thank you. Most of you, I assume, will know eBay. The one part that you might not be aware of is that today, on our mobile apps and websites, we already have over 500 million machine translations that are happening every day in 18 different language pair directions. Now, why do we have that? So we're really at the HMU level, hundreds of millions of users, 1.57 HMUs. And so in commerce, you're trying to be accurate in meeting the user's needs. The buyer wants to buy something, they have a certain intent. So we need to understand the intent of the buyer, sometimes even before the buyer even knows what they are exactly looking for. And we want to show them the most relevant inventory, and this becomes really complex if you think about you need to make these people happy at 800 million items and hundreds of millions of search queries every day. So how are we doing this at eBay? I'll hand it over to Hassan to give you some sense of what are we doing, how are we using deep learning, but also other advanced machine learning algorithms. And this is all things that are, not all of it, some of it is research, but a lot of this is actually live today in our apps, in our systems around the world.
Thank you, Mark. I'm going to go back one slide again, just to have the numbers get an impression on us. So 157 million users, active users, not users, active users, 800 million listings daily accessible for the users. And we are available in 190 countries, and as Mark said, 500 million translations daily. So I think those numbers are very, very impressive. So where do we use machine learning, and where do we use that science at eBay? These four areas are just areas which I wanted to mention. There's more areas than this. So one is user behavior and market analysis. Obviously, there's other companies which are probably doing the same. Natural language processing, we heard a couple of things like that, a couple of applications for that earlier. Machine translation, and computer vision and object identification. Those are the things which I want to mention because I will build upon them. So the use case I want to describe here is the use case of making our huge inventory accessible for multiple languages. So let's assume we are a Russian user. And we go to eBay before we do any of the language technology, anything of the machine learning algorithm. So the user will be able to see a site like the American user would see. They would be able to go in and type in a query. Their language, only 5 to 10% of people in Russia, for example, have a comfort in using English as a language. If they type in a query, they will not see any results if they use their own language. Now, what you can do is, as you see, 0 results. What you can do is you can translate the query and take the Russian query, translate it into English, and send that against the inventory. That helps. So what we did as a first step is query translation. So all the queries coming from Russia initially, then we came with other countries. It will give you the results back. But in English. So we had to do the next step. So we have the results, but the results are all in English. The third step is translate it back to the user into your language, which you have. So to be able to do that, sometimes you have to look. So machine translation is out there in the market for a long time. It's not new, and we also saw machine translation for speech input, which is noisy. We saw machine translation for tweets. We saw machine translation. I mean, this is all very, very. It's already in the market for quite a bit. Now, in our use case, we have our own domain. We have our own issue. If you look at this kind of title, for example, which we have to translate, it's a little bit of an issue. We have to identify more information, more semantic information out of a title to be able to do a good translation. So what we had to do is we needed to identify using deep neural networks, similar to what Richard earlier said. We use, for example, generating vectors out of words to learn what kind of content these words might have. So our named entity recognition system, which is basically riding on this, will take that title and understand some of the contents. It will say the size might be a 10, brand is French connection, type is address, and color is red. So these are information which we extract out of there. So there's two errors in this one. The color is Valentine's red, and 10 is not the size, but it is the amount. But generally, it helps me already so much more than using the words just as words. And really, it is a red dress. Another example: men, casual, sports, sweats, pants, harem, training, dance, baggy, jogging, trousers, slacks. The system identifies the style is casual and baggy. The occasion is sports, training, dance, and jogging. The type is sweatpants, harem, trousers, and slacks. And this is how they look. So all this, we can make use of our huge amount of data which we have, which is tagged by our users. Every seller tags automatically the information when they're putting it into the database. Unfortunately, not every user does, but we still can learn because we have so many information out there. The next thing we tackled is computer vision. We have a lot of information in images. So if you think about the 800 million items on a daily basis, as I said, 800 million items, 2.5 images on average for each item. So we have quite a bit of data, and as I said, daily, which means we have few billion and more data which we can learn from. So we use image processing, computer vision in two different tasks. One is for categorization, to identify what is that product and in what kind of category would it fit. This is an example. Desks and home office furniture for this image, for example, which is good. Breathalyzers, they're very well identified. And then also something which is a little bit more diverse. Flats and heels and sandals are different kinds of shoes which we identify. Now, as I said, we use also image process or computer vision for other tasks. We want basically the system to describe from an image what that product might be. Sometimes our system identifies only little, like this one. It's identified that this is a dining set because other information was not very confident. But then if you look at this example, for example, rustic barnwood, nightstand, single drawer. So it identifies the single drawer, the nightstand, rustic barnwood. This is all good information for the process of which or this example, twin over twin bunk bed. So it identified it's a bunk bed and identified also that it is a twin size bed. So this is good information. Why did we go into the computer vision task? So again here, it helps us to identify how to translate better. So that's why we started with this process. So if you have information which can be read from the image and infuse that information back into the actual decision, what to translate and how to translate, it will help disambiguation quite a bit. So while we are developing all this, we made these different tasks by themselves, which can be utilized in other workflows than actually making products internationally accessible. Here, the fourth example: vanity set, adjustable mirror, and stool walnut finish. I mean, it was quite well recognized. So, yeah, a very important part, a very very important part is that we we agree that the combination of different knowledge sources to make decisions is very important. So we use machine learning, regular machine learning algorithms like things which like reinforced learning and other things, and combine those with deep learning mechanisms for object identification, semantic parsing, etc., to get basically the best for the user. A very relevant issue is here that the research, our research, goes mostly in identifying what is the metric which we want to optimize against. This is very crucial. For example, if we do machine translation and so research usually use metrics to compare against, for example, human references. Machine translation, for example, every time in research people try to optimize towards a blue score or towards an automatically generated score, which is only an estimate or like an estimate to something which is right. Problem in machine translation, for example, you have so many different references which are correct. So sitting down and thinking about the best metric for a certain use case is very important. So what we did is our metric for machine translation is to see that the user behavior improves. So we put that metric in place where we see if implicit feedbacks like purchasing an item happen, this is a positive signal, and explicit feedback as well. If you give a star rating to the translation, this is basically our signal, which is stronger than just blue scores. And with the amount of transactions which we see on a daily basis, we can learn those metrics quite well. Maybe a guessing game. So we have titles which, I mean, people will barely be able to understand by themselves, like this one. I don't even want to read this. If you would not understand what it is unless you do where it is? Where is it? Here. You have to understand the context of it. For example, the categories where it was listed. It helps us already quite a bit to understand that it might be an insect of sorts, and the image will give us the missing clues basically to what it is, and that will give me enough information to do the machine translation. Similar to this one, flooded strand is an entry in our database for cards, which are thousands of times in our inventory. If you look at it by itself, it doesn't make sense. If you look into the category as a context, it helps. And then the image, it's just it's a card for a game. So yeah, that's the use case of where we use machine learning and image processing.
Let me end maybe with a few comments on we were trying to show you we are trying to really build this into our product. So this is not something that, Hassan works off in the research team and things don't ever make it out into live production. So I thought what I could do is share a couple of things of what have we learned about what does it take to make the advances that you can make with deep learning, machine learning, how to make those into real-life products. The first thing is really that you need to hire researchers that can be engineers and engineers that can be researchers. If those two groups are not hand-in-hand working together, and in a lot of cases they are the same people, it's very hard. You need to give them time to continue to participate in scientific forums. So you can't hire them out of academia, put them in a corporate environment, and then expect that they're going to continue to do the excellent work and advance the field as they have in the years before without the connections to the academic research and ongoing other interactions. So we have, visiting professors coming with us. We've got interns. A lot of companies who are active in this area know this. The researchers also, though, they need to stay with their ideas from inception all the way till it's live in production. They need to become entrepreneurs. And they need to make sure that they don't just throw the research over the fence. They stay with these products. And it's their product as much as it's the product of the product manager or the engineer or the interface designer or the person who has the profit and loss responsibility. It is their product. Now, if you're in a startup, that's probably relatively easy to do. You're just, you're like 10, 15, 20 people. Of course, everything is your product. In large companies, a lot of times that gets lost. The next area is really that kind of the whole team is responsible. So if you encounter a problem, you're trying to see something, you're getting some feedback from your customer support team. In our case, for example, sellers are wondering if somebody misunderstands a title that we've machine translated, are they then liable if a buyer isn't happy with the purchase? So you have to address those concerns, and that has to go all the way back to the researcher. So the researcher has to understand these are real concerns that the users of your more intelligent product actually have. Because the researcher actually has a chance to do something about it much more than when you try to do this very much later in the whole product development lifecycle. The other thing that I found really critical, and I really only learned this coming out of product management and mostly software engineering, really learned this cooperating with Hassan closely, was we need to take lessons from Agile and Agile engineering to a research mindset, especially machine learning. You iterate fast, you iterate quickly. So you need to have the ability to do that. So we need to remove bottlenecks and have the right support in place for these teams to be able to iterate. Specifically for us, that meant we have a team of 100% dedicated machine translation language specialists. This is not, some team somewhere else. They are part of the research team, because if you do machine translation without language specialists who can help you with human judgment and other areas, it is really hard to iterate fast. Of course, you also need to have the investment in the engineering systems to be able to, build, deploy, train, retrain all your models, which is another thing that helps you get into this iterative mode. And I'd say the last two things, first of all, you got to have a leadership team that understands that and is able to really bring together this team. That is something where, things like this conference or so and others really help educate the leadership team to the potential. And I would say the single biggest problem, if I summarize all of these, what's the biggest problem that I think we're faced with right now, that we're trying to solve, we're trying to address, is really that the product managers and designers a lot of times don't have the capabilities in mind when they look at user needs. So the user has a need. You're trying to solve a problem for a user. If you're familiar with the design thinking approach, it comes back to what is the user need? Define that really well. They then don't have in their mind the option of how to address that need unless they work closely with people like Hassan and a lot of you guys to address those needs in maybe completely different ways than you would have traditionally done that. So that's something that we're also trying to do, is to make the scientist an integral part of your product ideation and discovery phases.